Far below the ocean's surface, beneath the last traces of sunlight and warmth, exists a realm so alien that even the basic rules of life are rewritten. And in this realm, size is not a coincidence or an evolutionary accident, it is the difference between existence and extinction. The deep ocean begins where light can no longer penetrate, a boundary known as the Twilight Zone, and descends into regions of absolute darkness where vision becomes useless, temperatures hover just above freezing, and pressure increases to levels that would instantly crush unprotected human bodies. In this sunless world, there are no forests of plants, no steady food supply, and no predictable cycles of abundance. Instead, life survives on scraps drifting down from the surface, chemical energy seeping from cracks in the Earth's crust, or the rare moment when another living creature wanders too deep and becomes food. Every calorie matters, every movement is costly, and every mistake can mean starvation rather than death by predation. In such an environment, small bodies face a constant disadvantage because they burn energy faster, lose heat more quickly, and cannot store enough reserves to survive long periods without food. Over millions of years, natural selection favored creatures that could slow their lives down, conserve energy, and endure scarcity. And the most effective way to do that was to grow larger. Bigger bodies act like living batteries, capable of storing massive amounts of energy that can sustain an organism through months or even years without feeding. Larger size also means fewer natural predators, because in a place where encounters are rare, being intimidating can be enough to avoid conflict entirely. The deep ocean does not reward speed, agility, or constant activity. It rewards patience, stillness, and endurance, qualities that naturally favor large, slow-moving forms. As evolution experimented in this extreme environment, it gradually filtered out fragile designs and refined creatures into living fortresses. Thick-bodied, soft-tissued, pressure-resistant organisms built to last rather than to flee. Unlike surface animals that rely on constant movement to find food, deep-sea creatures often wait motionless in the darkness, conserving energy until opportunity comes to them, and waiting is far easier when your body can survive long stretches of emptiness. Over time, this selective pressure created a world where giants are not rare anomalies but logical outcomes. Where enormous crustaceans crawl slowly across the seabed, massive squids drift through black water like living shadows, and fish with jaws larger than their own bodies patrol a space where meals are unpredictable but lifespans are long. The deep ocean is also unforgiving in another way. It offers very few hiding places. There are no reefs dense enough to shelter countless small creatures, no plants to camouflage among, and no light to blend into, which means being small does not guarantee safety. In fact, small animals are often easier targets because they lack the size needed to threaten or intimidate, and in a realm where escape routes are limited, intimidation becomes a survival strategy. Larger animals can dominate space simply by existing within it, claiming territory not through aggression but through presence. This is why deep-sea gigantism is not about excess or mutation, it is about efficiency. In the deep ocean, efficiency is everything, and the most efficient form is one that minimizes movement, maximizes storage, and reduces vulnerability. The darkness itself encourages size, because without light, visual cues disappear and encounters become sudden and close, favoring creatures that can overpower prey instantly rather than chase it. When food finally appears, after weeks of waiting, there is no room for hesitation. Being large means being ready. Even reproduction is shaped by size, as larger animals can invest more energy into fewer offspring, increasing their chances of survival in a hostile environment where raising young is an enormous risk. Over geological time, this relentless pressure sculpted a biosphere that feels monstrous to human eyes, not because it is evil or unnatural, but because it is perfectly adapted to conditions we were never meant to experience. The deep ocean is a place where life stripped itself down to what truly works, and what works again and again is size. When we see deep-sea giants, we are not witnessing nature run wild. We are witnessing nature operating at its most ruthless and logical extreme, where the margin for error is so thin that only the largest, most enduring forms are allowed to persist. This is the world that shaped terrifying size, a world where being big is not impressive, it is necessary. To understand why life in the deep ocean grows to such terrifying sizes, you have to understand how radically different the physical laws of that environment are. because far below the surface, physics itself begins to favor gigantism rather than restrict it. As depth increases, water pressure rises dramatically, reaching hundreds or even thousands of times the pressure found at sea level, a force so extreme that it would instantly collapse lungs, crush bones, and destroy most surface-based life forms. Yet for deep-sea creatures, this crushing pressure is not an enemy, it is a stabilizing force. Unlike land animals, many deep-sea organisms lack rigid skeletons or air-filled cavities, instead developing soft, gelatinous bodies that distribute pressure evenly across their tissues, allowing them to grow larger without structural failure. In a strange reversal of surface biology, pressure actually supports size rather than limiting it, enabling enormous bodies to exist without collapsing under their own weight. Cold temperature further amplifies this effect, as the deep ocean remains near freezing year-round, creating an environment where metabolic rates slow to a crawl. A slower metabolism means that deep-sea animals burn energy far more efficiently, requiring fewer calories to survive and allowing them to live much longer lives. Longevity is a critical ingredient in gigantism, because when an organism lives for decades or centuries instead of years, growth becomes an ongoing process, rather than a brief developmental phase. Many deep-sea creatures never truly stop growing, they simply grow more slowly, steadily adding mass over immense spans of time. Cold water also carries another advantage for large bodies. It holds more dissolved oxygen than warm water, reducing one of the greatest constraints on size found in surface animals. On land, large bodies struggle to deliver enough oxygen to their tissues without overheating, but in the deep sea, cold temperatures and oxygen-rich water allow even massive organisms to breathe efficiently without the risk of thermal stress. This combination of pressure support, metabolic efficiency, and oxygen availability removes many of the natural size limits that govern surface ecosystems, opening the door for evolution to experiment with scale. Over millions of years, this environment selected for creatures that prioritize bulk over speed, endurance over agility, and efficiency over constant activity. Muscles became slower but stronger, tissues became softer but tougher, and bodies became larger without becoming fragile. The deep sea also lacks one of the most important constraints on size found on land: gravity. While gravity is still present, buoyancy counteracts much of its effect, allowing massive organisms to exist without eating thick bones or powerful limbs to support their own weight. This is why deep-sea giants often appear oddly proportioned, with long limbs, thin muscles, or fragile-looking bodies that would collapse instantly on land, yet function perfectly underwater. Even reproduction is influenced by these conditions, as slow metabolism and long lifespans favor fewer reproductive events spread over time, allowing individuals to invest more energy into survival and growth rather than constant breeding. Over evolutionary timescales, these subtle advantages compounded, gradually favoring larger individuals who could better withstand pressure, store more energy, and survive longer between meals. What emerges from this process is not randomness, but a predictable outcome, a biosphere where size is not punished but rewarded, where growing larger increases efficiency rather than cost, and where physical forces quietly push life toward gigantism. The terrifying appearance of deep-sea giants is not the result of mutation or excess. It is the logical consequence of an environment that removes nearly every barrier to growth while relentlessly punishing weakness. In the deep ocean, biology is shaped not by sunlight or speed, but by pressure, cold, and time, and given enough of all three, life does exactly what physics allows it to do: it grows. In the deep ocean, hunger is not a temporary condition. It is a permanent state that shapes every aspect of life, and it is this relentless scarcity that pushes evolution towards size, excess, and terrifying efficiency. Unlike surface ecosystems, where food is renewed daily through sunlight and plant growth, the deep sea exists on leftovers, relying on a slow, unpredictable rain of organic debris sinking from above, occasional chemical energy from hydrothermal vents, or the rare arrival of another animal drifting into the darkness. For many deep-sea eaters, a significant meal may occur only a few times in an entire year, and missing one opportunity can mean slow starvation rather than immediate death. In such an environment, natural selection favors animals that can take full advantage of rare encounters, and the most reliable way to do that is to be able to eat anything, anytime, without hesitation. This pressure gave rise to the signature features of deep-sea giants: enormous mouths, expandable jaws, oversized teeth, and stomachs capable of stretching far beyond what seems biologically reasonable. When food appears, there is no room for selectivity or pursuit. The deep sea rewards creatures that can engulf prey whole, even if that prey is nearly as large as the predator itself. Large bodies make this possible, allowing animals to store massive energy reserves that can sustain them through months or even years of emptiness. This creates a brutal feedback loop, where larger individuals survive famine more easily, live longer, and therefore have more time to grow even larger. Hunger also shapes behavior, favoring ambush over chase, patience over speed, and intimidation over conflict. Many deep-sea giants drift motionless in the darkness, conserving energy until prey comes close enough that a single movement is enough to secure a meal. In this world, chasing prey is inefficient and dangerous, but overwhelming it instantly is reliable. Size becomes a weapon not just for feeding, but for survival itself, because larger animals face fewer predators in an ecosystem where encounters are rare and escape routes are limited. Smaller creatures must constantly expend energy avoiding threats, while giants can dominate space simply by existing within it. Even sensory systems evolve around scarcity, with many deep-sea animals developing heightened sensitivity to vibration, pressure changes, or faint chemical signals, allowing them to detect rare opportunities from a distance without moving. When those signals appear, the response is immediate and absolute, because hesitation wastes energy that may never be replaced. Over evolutionary time, this unforgiving logic transformed ordinary body plans into extreme forms, producing fish with jaws larger than their bodies, crustaceans the size of suitcases, and squids with arms designed to seize anything that moves. These creatures look monstrous not because they are aggressive by nature, but because they are perfectly adapted to a world where mercy does not exist and abundance is a myth. The deep sea does not produce beauty through balance, it produces survival through excess, and hunger ensures that excess always favors those who grow bigger, wait longer, and strike once. Despite centuries of exploration and decades of advanced technology, the deep ocean remains one of the least understood environments on Earth, and this vast unknown suggests that the story of deep-sea gigantism is far from complete. Humans have explored only a tiny fraction of the seafloor, leaving immense regions of abyssal plains, trenches, and underwater mountain ranges, completely unmapped and unobserved, hidden beneath kilometers of water and darkness. Every time a deep-sea expedition descends into these depths, it reveals species that defy expectations, creatures larger, stranger, and more extreme than anything previously imagined. Many of the largest deep-sea animals known today were not discovered through direct observation but through fragments and indirect evidence. Massive beaks recovered from the stomachs of sperm whales, unexplained bite marks and scars on the bodies of the ocean's largest predators, and sonar readings that detect enormous moving shapes that vanish before identification is possible. These clues suggest that some of the largest inhabitants of the deep OCE and may still remain unseen, living in regions too deep, too remote, or too fragile for frequent human exploration. The challenges of deep-sea research, crushing pressure, limited visibility, and the immense cost of deep-diving missions mean that our understanding of this ecosystem is shaped by brief glimpses rather than continuous observation. Unlike surface environments, where animals are constantly monitored, filmed, and cataloged, deep-sea life exists largely beyond human awareness, evolving slowly and independently over millions of years. This isolation allows gigantism to persist without interference, unchecked by hunting, habitat destruction, or environmental disruption that limits size in many surface species. Even today, scientists regularly discover new deep-sea species that display traits associated with gigantism, reinforcing the idea that size is not an exception in the deep ocean, but a recurring outcome of its conditions. The sheer scale of unexplored territory raises an unsettling possibility that the largest animals on Earth may not be whales, but creatures that live far below them, in regions no human has ever seen alive. As technology improves and exploration pushes deeper, each discovery challenges our assumptions about biological limits and reminds us that the deep ocean is not a finished chapter in natural history, but an ongoing experiment in scale. In a world where evolution has had hundreds of millions of years to refine survival without observation, it is entirely possible that the most terrifying giants are not relics of the past, but living inhabitants of the present, hidden in darkness, growing slowly, and waiting beyond the reach of human light. What makes the giants of the deep ocean truly terrifying is not just their size or appearance, but the cold logic that created them. Because once that logic is understood, it becomes clear that these creatures are not anomalies or mistakes. They are inevitable. The deep sea is an environment stripped of comfort, abundance, and forgiveness, where every advantage is measured in efficiency rather than strength, and where survival depends on endurance more than aggression. In such a place, evolution does not reward speed, beauty, or complexity. It rewards solutions that work for the longest possible time under the harshest possible conditions. Growing large is one of those solutions. Larger bodies store more energy, survive longer without food, resist pressure more effectively, and reduce vulnerability in a world where escape is limited and encounters are rare but decisive. Over millions of years, this advantage compounds, favoring organisms that grow slowly, live long, and dominate space through presence rather than activity. These giants do not need to hunt constantly or fight frequently. They wait, conserve, and endure, existing as living embodiments of patience in a realm where time moves differently. Their terrifying features, massive jaws, expandable stomachs, alien proportions, are not designed to frighten but to ensure that when opportunity finally appears, nothing is wasted. In this sense, deep-sea giants are not monsters in the traditional sense. They are efficient answers to an impossible environment, shaped by pressure, cold, darkness, and scarcity, into forms that feel unnatural only because they reveal a version of nature unconcerned with human comfort or aesthetics. The fear they inspire comes from recognition, from realizing that if Earth's conditions were slightly different, if darkness replaced sunlight and scarcity replaced abundance, this is the kind of life that would dominate everywhere. The deep ocean shows us what evolution looks like when constraints are removed and survival becomes the only goal. And in doing so, it offers a glimpse of a world where size is not excess, but necessity. These giants are reminders that nature does not grow kind or gentle in extreme places. It grows practical, relentless, and indifferent. And when given enough time and freedom, it grows big.